Welcome to the OpenCV course, where you're going to explore the fundamentals of computer vision and image processing using OpenCV, which is one of the most widely used libraries in the field. OpenCV plays a very crucial role in AI, machine learning, robotics, and automation, enabling applications like face recognition, object detection, and image enhancement. This course is designed to take you from the basics to the advanced techniques, covering key topics such as setting up your environment, understanding essential Python libraries, and working with images like loading, displaying, and manipulating them effectively. You'll also learn how to handle multiple images, draw and annotate visual, and apply various image processing techniques using filters, transformation, and edge detection. Additionally, the course includes real-world projects to help you gain hands-on experience, along with best practices and standard operating procedures to enhance your workflow. By the end of this course, you will have the skills to develop image processing application, perform object detection, and optimize images using OpenCV. So guys, get ready to dive into the world of computer vision and start building the exciting projects. But before we move on, just a quick info guys. Simplilearn has got Artificial Intelligence Engineer Master Program in collaboration with IBM. You can earn a recognized AI Engineer certification to boost your career, learn machine learning, NLP, deep learning, generative AI, and many more. You can master in AI by doing real-world projects using industry-aligned tools. And finally, you can earn IBM certificates and benefit from the masterclass by IBM experts. So guys, hurry up now and join the course. The course link is mentioned in the description box. So let's get started.
Hello and welcome to OpenCV Crash Course 2025 from Simplilearn. Today in this course we are going to talk about OpenCV framework of Python, which dealing with the image data, and we will work on the course which talks about how to do certain actions with the images. So what shall be covering up in this course would include introduction to OpenCV library, some prerequisites and the skills that are required to go through with image manipulations or certain actions with the image. Tools and the environment setup would require us to talk about different tools that can be utilized for the purpose of working with the OpenCV library, and environments would be setting up OpenCV library in that particular tool. Then I'll also introduce you certain basic Python libraries that are dependencies for OpenCV, or I would say that these are required in order to go the internal details of the image manipulation or image processing. Next, we will start up from the very basics like displaying the images and how do we manipulate certain images. Under manipulation part, we will talk about, let's say, how do we handle multiple images, how do we handle the drawings and the annotation on the images, and then we shall talk about some basic image processing techniques, such like blurring the image or transforming the image or rotating the image, certain examples. And as a part of real world project, we shall be talking about a face detection algorithm. So we'll be using a pre-trained model for face detection provided with OpenCV library that can be easily implemented and can detect faces on a static image. At the last, we will talk about the standard operating procedures and the best practices that we should follow during the work with OpenCV library. So that would be our agenda that we'll be covering up through with this course. So let's get started. I'll introduce you what is OpenCV library. So OpenCV library is a library that is precisely built on for the purpose of computer vision and image processing. It has many tools which are given for us for object detection, facial recognition, edge detection, and video analysis. Now, OpenCV library is one of the aspects of deep learning community where we try to replicate what neural networks have tried to achieve for one of the human sensory organ, that is eyes. That is to actually visualize an image and make informed decisions about that image. For an example, try to rotate an image for certain degrees, maybe blur an image, or you can try to create multiple images from of one single image. So there is a lot of things that could be done as a part of computer vision, or maybe identifying an image or detecting an object. All the applications that are using computer vision for the moment right now would be working on the platform of OpenCV and like to understand how an image could be read up, and we can work around with the image and make informed decisions in order to work in a real world environment. How does OpenCV work? Uh, OpenCV actually takes up the advantage of recently developed CUDA environment. I'll see that as CUDA, which is actually using up hardware resources to deal with a bigger amount of data. Because if you understand, through image is a huge data if I talk about, because each image is divided into number of pixels, and if you have an image which is of high resolution, that would mean millions or billions of pixels could be there. So dealing with that much huge amount of data would definitely require a lot of hardware support. OpenCV actually uses the available hardwares in a high performing environment and gives us a result in a very fast manner. OpenCV actually leverages the TensorFlow library, and it takes up uh, the working principles behind it to work around. OpenCV is available on Python platform. It is available on C language platform. So you can use or integrate OpenCV library through Python, or you can integrate through C++. Some basic examples where OpenCV is actually used in real-world applications is face detection algorithms, self-driving cars, or in the healthcare segment. If you talk about in face detection algorithm, we will work on some real-time project on face detection where we will work on a static image, try to extract features from that image and work on features to find out a face, and in that face we'll try to locate up the eyes as well so that we can measure out where is the face. That's what we can do. Also, it can also be used in self-driving cars. We can have camera mounted up on the cars everywhere, and these cameras will detect live images and will find out what is the object that is coming through. Is it a moving object? Is it a static object? And if it is being employed in a car that is going to do a self-drive, then how does it can make an informed decision whether to avoid an object, whether to hit an object, or whether to change lane or do any other activity. Similarly, OpenCV is very useful in the healthcare sector as well, where it allows us to actually look at the images of magnetic of the pathological examination or radiological examination that generate magnetic images like MRI scans or X-ray scans, and we can make informed decisions. Now, that could have been not very convenient or easier for any other person, or maybe a human interpretation of that might miss out on certain things. These models or OpenCV models are capable enough to capture every small single entity or smallest possible feature from an image and try to interpret that. That's what we can do with the OpenCV library, or in particular with the computer vision. Let's talk about the prerequisites and the skills required for computer vision. So what we require for computer vision or understanding OpenCV library is a basic understanding of Python programming language. That's what we are going to use in this course. So to work on OpenCV, we require a programming language where we can integrate with OpenCV library. There are two or three languages where you can integrate OpenCV, but Python is the most recommended one because of its availability and its faster processing of the data. The other languages which can integrate with OpenCV are C++ and Java. So depending upon what is the comfort zone that we have, we can either use C++ or Java. We shall be aligning with Python language because that's in demand these days, and people have easier understanding codes written in Python as compared to C++ or Java. Then we have to also understand about the computer vision basics, as in what is an image, how do we read an image, what is a multidimensional array, and how image is interpreted or stored or actually read in the machine learning environment as a multidimensional array, where we talk about what is a pixel, how do we can read a pixel, and work around with the pixels. So that is a typical understanding of the image that is being talked about. We have two different types of images you can say in real world. One is a grayscale image, which we consider as a two-dimensional array. And when you talk about a typical colored image, which is a combination of three basic colors, that's a red, green, and blue. So RGB, what we call that as. So we can have an RGB image or we can have a grayscale image. A grayscale image is a 2D array and an RGB image is a 3D array. When I say 3D array, each layer, or I would say that the third dimension of that array typically suggests one color channel. Like we have red channel, green channel, and the blue channel. Superimposing all those three channels all together generates a new color. And that is why we can see different types of colors. The values of the colors we will be using up is in terms of hexadecimal notation, and we will start from 0 and we'll go till 255. So we'll be using 0 to 256 colors, and those colors will define low intensity and high intensity of colors. We also require to understand or have an understanding of basic linear algebraic transformations or understand basic matrices. The expectations is that we have understanding what is addition of matrices or a multiplication, or we can understand what would be the eigenvalues and eigenvectors. Also understand if we know dot product and a cross product of matrices. In a nutshell, if I talk about all the processing that we perform on an image would be a processing of image considered as a NumPy array or a matrix, and we will apply certain matrix-based transformations. We'll see some of those transformations in this course as well. These transformations will allow us to have some operations to be done on an image. This can be filters on the images, this can be convolutions on the images, or any geometric transformations like rotating or scaling the image. As we have talked about, that NumPy, that the images would be read out as a NumPy array. So we need to have a good understanding how to deal with the NumPy library and different functions which are available through NumPy, conversion of an array into a NumPy form, resizing of array. These will be the basic aspects that we'll be doing with the NumPy arrays, or do some numerical operations like dot product or cross products or addition or multiplication. We can also utilize Matplotlib library, which is a basic Python library used for visualization, to actually visualize the images. Though in this course, I will not be using Matplotlib. We shall be displaying images through OpenCV only. Moving ahead, let's talk about the tools and the environment setup. In terms of environment, let's talk about the features and the tools that we can use. Now, typically, if we talk about an OpenCV project or an image processing project, you will require a tool either for the deployment purpose or for the model creation purpose. So what tools that we are going to use right now is for the model creation, which would be working in a current environment, and we will be able to use that upon a machine. Maybe if you want to deploy it on a web server, or if you want to use it for an application, you might need a different environment for that purpose. We are not going to deal with the deployment section. We will be dealing up only with the model creation part. So in order to begin with the OpenCV library, we first need to install OpenCV library into our current working environment. Now, in terms of working environment, there are multiple tools that we can use for the OpenCV library with Python. And the tool that we are going to use is a Jupyter Lab environment. Now, that Jupyter Lab environment is available through cloud services of Jupyter Lab. It is available on Google Colab services. It is also available through Anaconda distribution. So either way around, you can use it as per your convenience. I shall be using up this environment on my locally installed Anaconda notebook, and I shall be using up Jupyter Lab environment through that Anaconda. So we shall be looking at how to install OpenCV library in a short while from now. As we talked about the environments, you can use multiple environments like VS Code, you can use Jupyter Notebook environment, which you are going to use, or we can use PyCharm, which is again a very good environment in terms of, because PyCharm can commonly be used for creation of the model as well as for the deployment of the models. We have subtle difference in terms of the how these tools are being used, or how these tools are going to give me the results. So if you have to look for intermediate results and work on intermediate results and try to analyze those results and work along with that, we will prefer using Jupyter environment. If you're creating up an application or a web service, you would prefer using either a VS Code or a PyCharm platform. OpenCV also comes up along with an additional version. Now, OpenCV by default it does not contain some advanced features. Something like we can say that there's a Sift module which is available in OpenCV, which allows us to use some additional features of OpenCV library. Sift module, if I talk about, is a scale invariant feature transformation module that allows us to perform some additional variation to the images apart from what basic variations you can do. So if you have to use some advanced versions of OpenCV, we can install OpenCV with Contrib, and I'll show you that too as well in a short while. How do we do that? We can also use Photoshop or label image like third-party tools, which can allow us to create or modify images for testing purpose. Same image, you can maybe enlarge it, compress it, or maybe add certain objects to it, and maybe can try with that. So that will be the optional tools that you can think of, like Photoshop or label image or OpenCV with Contrib. Let's talk about some basic Python libraries that I'll use for OpenCV. That will not include too many things, just a simple things. As I've discussed before, we shall be implementing the NumPy library for manipulating the image arrays. We will be using Matplotlib for displaying and visualizing the images. And the two other libraries that I'll be using up is OS and Glob. Now, out of this Glob, I will put it as an optional object. But yes, OS would be required as we are going to deal with how to read images from a folder in a drive or in a directory. That's a part of this module that I'm trying to take up. When we talk about OS and Glob, OS is an inbuilt module which is available with Python and allows us to interact with the operating system that we're using. So we can traverse through the paths of the operating system in my drives and access folders and file names from there. So we shall be looking at OS and Glob library as well. Moving ahead, let's try to talk about displaying and manipulating images. That's the first topic. So in order to display and manipulate images, we have three different functions. And before I move to this section, let's try to go on to a Jupyter Lab environment. So let's go there. So here is my Jupyter Lab environment. I have already pasted up certain codes for this, and I will be walking through with those just to save on time. So the first thing that we'll talk about is how to install OpenCV library. In order to install OpenCV library, we need to write down this that says pip install OpenCV-Python. Now, where pip is Python preferred installer that allows us to install libraries on Python environment. So we are using a Python environment on Jupyter Lab platform. So I'll just go through with that. Execute it the same, and I'm expecting that it would say requirement already satisfied because this library is pre-installed on my machine. If it is not pre-installed on a machine, it should say downloading some softwares from the resources. You need to be connected to the internet for this, and it will download the software and it will install it. So in a similar fashion, you can also install the Contrib part of OpenCV, which I'll show you here how to install the OpenCV with Contrib. So that's how it works. Pip install opencv-contrib-python. This allows us to get the OpenCV contrib version. You can see I have OpenCV version 4.11.06 and that is installed, and the contrib is an extension to that, which is 4.11.0.86 that is already there. You can also see here that it also requires a dependency of NumPy library. So OpenCV has all its module or all its functionality dependent on NumPy library. NumPy in itself has certain dependency on basic Python libraries that you can visualize by installing the NumPy library. Let's talk about what do we mean by display, read, and write image. So I have an image in my hard drive, which is in my current working folder. So if I just show you that part, in my current working folder, I can utilize my current directory. So I'll import a library, which is OS, import OS, and I'll display what is my current working directory. So let's show that. os.get current working directory. And I'll execute that, and it tells me this proportion. So currently I'm working in this directory, that is some users, some name, and downloads. And there I will have this working file right now. So if I put up my images, whichever I'm trying to process, in the same location, I do not have to put up the entire path here, wherever. So I can use either that way, or I can replace that with the entire path. I can replace the same information with the path as well. So I can put it that, and I'll put here, and that will also work for us. So either way around, you can use it both ways. I'll stick to the same portion. As a remembrance, please ensure that the image that you want to process and the file that you're working with are in the same folder, just to follow the same code, correct? Now, so first thing first, we have already installed the OpenCV library. From here, this library gets installed on my machine, and it comes by the name CV2. Now, that's a name given by OpenCV for it. Computer Vision 2, it's the name for OpenCV library. So I'll import OpenCV. I do not need anything else right now. Now, in order to read an image, what we can write down is cv2 dot, that's my library cv2 dot imread is a function available in cv2 library, and I can just tell the image name. So, or I can mention the image path. That's how I have read this image in a variable called as image. The variable image is exactly a NumPy array. We'll show that in a short while from now. So that's how we will look at the image. We have read an image using a function called as imread. Moving ahead, we will display that image. In process of displaying that image, what we need to do is the same function that we have used earlier, imread. Just modify that function to imshow. Python, being a user-friendly language, has given the function names in a very user-friendly manner. Now, in imshow, which stands for image show, imread stands for image read. So what does the imshow is going to do? This imshow will pop out a new window, and that window requires a title. So I need to put up two properties to it. One is the title to the new window in which it will display the image, and the second one is the array which we are going to display. This is a NumPy array, a three-dimensional NumPy array, and this array is going to be displayed using the cv2.imshow. Next, I have written down a statement which is cv2.waitKey0. Now, what does that wait key stands for? This wait key function is typically used for us to let manually or automatically close the pop-up window which is going to display the image. So if I put the value 0, that means wait until there is a key pressed, or wait until I close it from the cross button of the new window. Or else, if I can mention here a timer, let's say I mentioned, let's say 1200. That means it has to wait for 1200 seconds before it closes the image or image window. So I'll keep it 0 for now because I want to manually close it. Next, just to show the differentiation, I have used this property, which is an image conversion part, which I'll explain in a short while, where I'm trying to convert an image to a grayscale image. So we can leave it that part right now. In this step, I have converted the image into a grayscale image. But just to display that grayscale image, I have saved that grayscale image in a variable that's a gray image. This gray image is again going to be a NumPy array. It's again going to be a NumPy array where I have modified this image. This is a pre-created filter available with OpenCV, so I do not have to look into the mathematics of it. We can directly utilize it. One important thing that we need to understand is that OpenCV reads the image in a BGR format. Now, that's a very crucial thing. When I say the BGR format, what does that implement or what does that indicate? A BGR format would mean that I am reading the blue layer of the image first, then the green layer, and then the red layer. If you talk about any digital imaging device like a camera or anything else, that reads the image or that creates the image in a RGB format. That means the red portion is on the top, then the green format, and then the blue format. So there is a subtle difference in the formation of the layers of the NumPy array. Otherwise, if you take about the superimposition of all these three layers, the color would come up same. Coming to this part, the next function that I'm using here is to display that grayscale image. Same function as we use in IMShow for original image. Same function here. Also, in order to save the converted image or any image that we have processed, what we can do is we can use a function called as IMWrite. Using the IMWrite function, we can save an image. What we have to give the properties as, that is a gray image.jpg is the name of the file that I wanted to save in my drive. And secondly, the array name that I would use for this purpose. The array that I want to save as a JPG image. So going through with all this information, let's go through. So that should have displayed somewhere, and I can see the original image here. It's displaying up here. So this is my image that I've imported from Google server. I did a Google search and found out this image for NASA astronauts. I can see Miss Kalpana Chawla there. The one name that I recognize. Apart from that, I cannot see anyone which I recognize. Nonetheless, so this is a grayscale image, this is a original image that I have read from internet resource. I downloaded that image and used that image here. You can take up any image of your choice. You can download any image and work on that image. You just need to make sure that the image is in the same folder and you have the same file name. I'll close this image and immediately you see that I have used the IMShow function for displaying the gray image. That's what you see here right now. As a part of this code, the step number 5, the grayscale is being displayed and it will remain on my screen until I close it. So I'll close it from here. Done. This is the first aspect of image transformation. So we have been talking about how to display images or manipulate images. We have seen how do we read images through IMRead function. We have seen how do we display images through IMShow function. And we have seen how wait key is used to hold the image on the screen on the pop-up window. The destroy all windows function is used to release the memory which is utilized by the pop-up windows by CV2 library. So it's a good practice to put up destroy all windows function whenever you are using the OpenCV window to pop up and display the image. We've also seen how do we use CVT color function typically to convert an image from any format to any format. Like BGR to grayscale is something that we've just observed through the previous code. We have also seen how we can work to use a function called as IMWrite to save an image or a processed image that we want to put it up for future use using IMWrite function. So we can read, write, and display the images using OpenCV library. Next, we are going to talk about how do we handle multiple images. In terms of handling multiple images, what we are trying to talk about is if I have multiple images and I want to, let's say, stack them using a side-by-side representation, or maybe I want to put them across in a vertical format, or I might want to do it through in a maybe in a grid format. There can be multiple ways by which you would like to handle multiple images. So CV2 comes with inbuilt functions like hconcat for horizontal concatenation. We have vconcat function from CV2 for vertical concatenation, and we can combine these two functions together to create grids as well. So that will be handling multiple images or creating the multiple images grids or custom grids using OpenCV. We'll be doing that. Also, we'll also look at how do we read different types of images from a particular directory. Any directory on my hard drive, how do I read those images? We'll work on that part. Moving ahead, we will be talking about how to draw or annotate images. Before proceeding further on drawing and the annotation part of this, let's go to the portion where we'll talk about some more manipulations that we can perform on an image. Also, we'll talk about how do we put up the horizontal concatenation, vertical concatenation, and creating the custom grids. Let's go to the Jupyter Lab environment. So first thing first, we need to understand, I'm going to use the same NASA image that I've used earlier, and I'm going to talk about how do we resize the image. Now, 2 or 3 important things that we are working on this here is how can we resize the image and how can we crop an image. When I say cropping and resizing, that includes 2 aspects. The first aspect is resizing is to resize the dimensions of the frame in which the image is going to be displayed. That typically means I am just changing the size of the array to a different size and extending or stretching those pixels. That is what we're trying to do in resize option. Again, it's an easy task to do. What we can do is we can read the image through the image read function. In order to resize the image, we use a resize function given with OpenCV library. So I've used cv2.resize, just like resize function that you have in your NumPy library that allows you to add extra information. Similarly, here you can do that image. I'm resizing my image to 800 by 600. That means here that 800 represents the width of the image and 600 represents the height of the image. This is in terms of pixels. So 800 pixel by 600 pixel. I am resizing my image, which was earlier a little more longer and highly with a less height that you've seen earlier. In a similar way, we can also, as we do a selection of a particular portion of an image, or we say that we can do a slicing in a NumPy array. In a similar fashion, it is also a NumPy array, and I want to take up a slice from that image. So that would be kind of cropping the image. In order to crop the image, I can use this image that I originally had, and I can create a crop of that image by using the slicing function or slicing values. So here I'm asking this cropped image to have values from the image from starting from pixel 50 to pixel 250 on the width part and pixel 100 to pixel 300 on the height part. So this is some center portion that I'm trying to find out and look at those. Later on, I have saved those images in my computer memory and displayed those. Very simple thing. Again, repeating that part, resize, I can use to resize the image. And in order to crop the image, we will take a slice of that image just like NumPy slicing. Let's have a look. Now you can see that this image looks like a cropped, looks like a little bit more enhanced image as compared to the previous one, which was slightly half of it maybe. And in this image, you can see the dimensions are 800 in width and 600 in the height. That's the idea behind it. Similarly, I'll also show you the cropped image. This is the cropped image that we have. In this cropped image, you can see it has highlighted one particular portion which would be from maybe that we have chosen out is 50 pixel to 250 pixels. If you look at this here, so we have chosen out 50 to 250 pixels on x-axis. You can put up, let's say, try in a different portion maybe. Let's try to have a look at 150 pixel to, let's say, 200 pixel. So a little more smaller image. Height wise, I'm keeping it same. So this is the enhanced image. So you can see that the image it's capturing from 150 pixel to in the width form and lesser in the height form. Thank you. So that works around with your pixel. So again, repeating myself, the first attribute here represents the height and the second attribute represents the width. So it's height, comma, width of the image. That's rows and columns of the array. Coming to the rotating and scaling of the images. Again, in order to rotate the image in order to scale the images, we have to do a small little activity, a very small thing. See, when you're trying to rotate an image, the image rotates around a center point. There will be a center point around which it is going to rotate. Wherever point or along a particular axis or along a particular value, you want to rotate an image. Typically meaning that we want an image to be transformed or rotated where I will keep one of the pixel as a static and remaining pixels will rotate around with that pixel. That is what we're trying to do. Again, reading the same image that is from NASA. I'll read that image, and then what we're going to do here is to rotate or scale the image. So in terms of rotation, I'll rotate it by 45 degree for you. Also scaling it down or scaling it up, whatever we want, we can do that way. So again, that can be done through the resize function as well. So let's talk about that. So what we have captured here in order to rotate is the first two attributes of my image. As I've told, that image consists of it's a three-dimensional data that will contain height, width, and the third one is the RGB channel. So, or BGR channel if it's read through OpenCV. So the third dimension of that image represents the BGR channel, which I want to capture all. But what I want is the height and the width of the image. So I've captured that through the shape function, just like NumPy array, because image, when read through with CV library, it is a NumPy array. So for that NumPy array, I'm using the shape function and capturing the first two attributes of the shape, that would be height and width. And I'm saving that as height and width in H and W variable. Then I'm trying to find out the center of that. So dividing that by 2 and taking the absolute values of that. So I'm getting my center value that will be in terms of fractions just for the ease of convenience. I'm changing that width by 2 and height by 2. So my center value will be the absolute value of division of width by 2 and height by 2. So dividing my width and height into two equivalent portions and taking the absolute value to become a center. This center is what I will use to rotate the image. Once I got the center, I will use a CV2 function called as getRotationMatrix2D that tells me to rotate a two-dimensional image. Now, we have a two-dimensional image which is formed through a three-dimensional array, but its image is a two-dimensional image. So we will rotate that two-dimensional image on a particular center by a particular degree and with certain scaling factor. Now that's the second part, third part. So what we're trying to do, whether I want to scale that image to some different level or not. So three things. What is the center value? What is the amount of rotation? And what is the scaling factor? How much I want to scale that image. If I want to keep the image shape as it is, I will keep the scaling factor as 1. Otherwise, if I want to enlarge it, I'll keep it more than 1. If I want to reduce it down, I'll keep it less than 1. So that's 100% scaling. Then this will generate a matrix. What is this going to generate? It is going to generate a transformation matrix. It is not going to transform my image. It is going to generate a matrix that will allow us to transform an image from a particular pixel value, whatever the value of H and W were, at that pixel value, it will start transforming. I could have mentioned any pixel value here. It will rotate by that much degree from that pixel. Once we get that done, we apply this rotation matrix to the original image. Now, for any kind of transformation in the image, CV2 has given up a function that is warp affine. Warp affine function applies any kind of transformation, any transformation, geometric transformation we talk about, applies that to our algorithm about our image on certain parameters. So we can find out our rotated images by using cv2.warp affine. Warp affine is going to apply a certain transformation matrix to a particular image. So if mention the image and the transformation matrix and the size and the width and the height of the image through things that I'll put up. That's what we'll get from rotation part. Similarly, you can also use it for scaling. So see, resize function we have already used earlier. I'm not telling it the shape part here, image comma shape. I'm not showing the shape part, but I'm telling it how to scale it. F of x and f of y are two parameters which allow us how much I want to scale on x-axis and how much I want to use it on the y-axis. So I can use a custom scale instead of putting the pixel. That means when I put fx and f of y, f of x and f of y, what does that mean? That value means I want to scale my image by whatever the number that is. 0.5 means 50% of the current pixel value. So if I have 800 pixels, I'll make it 400. If I put 0.5, if I put maybe 1.5, that will become 800 to 1200. Increase it by 0.5%. Okay, so that is how you can resize the image. Next, we have done the standard procedure of writing down that image to my local drive. We have talked about how to display the image. So I'm displaying all the images, the rotated image and the scaled image. So you can see that this image is rotated by 45 degrees. The rest of the portion is clipped off because I did not change my canvas size. So rest of the portion is coming up as clipped off. Similarly, you can see the scaled down image. This is a scaled image that I have put up 50%. So height is reduced by 50% and the width is reduced by 50%. Next is image thresholding. We'll talk about that. Let's back to the presentation. So in terms of drawing and annotating images, what exactly I mean to say is at times you would want a particular image to be selected for drawing up a particular shape onto that image. You might want to draw up a square, you might want to draw up a rectangle, you might want to draw up a circle or a line for your choice, maybe a tilted line or a vertical line or whatsoever manner. So we look at how do we draw these things. We have functions available to draw rectangle as cv2.rectangle. To draw circle, we have cv2.circle. To draw a line, we have cv2.line. We'll be implementing those. Also, we have you might also want to add some text onto that image. If you want to add certain text onto the image, we can use that by using cv2.putText. We have options how to position the text, what is the color and the thickness of the text, and what are the font types and font sizes. So multiple choices are available in terms of drawing or annotating the image. Then we'll talk about image processing techniques. We'll keep it for a hold for a minute. Let's go back to our previous observations on OpenCV. And we'll first talk about, we'll come back to image thresholding later, which I've talked about here. We'll talk about drawing shapes first. So how do we draw shapes? In terms of drawing shapes, it's an easy task that we're going to do. To draw shapes on the image, what we can do is, what we're trying to do is first create up a simple blank image. In order to, or you can say that as a blank canvas as well, I am using NumPy library. You can see that I have generated an array, a three-dimensional array, np.zeros, which is all filled with zeros. np.zeros will generate an array which will be all filled with zeros, and that zeros values are going to be filled up in a 500 by 500 by 3. That means I'm creating a three-dimensional array where I have 500 rows, 500 columns, and there are 3 layers to it. I'm taking D type as unsigned integer of 8-bit just to save on memory part. You can also take up a 4-bit integer. That's your choice. by default, it will be going to 32 or 64-bit integer. I want an unsigned integer of 8-bit so that I can save on my memory. Not a lot of space is consumed in creating that image. Now, in this image, I'm going to draw a rectangle, I'm going to draw a circle, I'm going to draw a line, and then it'll display the image using IMShow and save that image. Finally, I'll wait for a key to press in order to close the window, and we'll destroy the windows. So how do we create a rectangle? Three important aspects. cv2.rectangle is the function that allows us to create a rectangle. Few things where I need to tell it where to put that rectangle on. So I need to tell which array I'm trying to put the rectangle on. That will be my array of image. So image is the array in which I'm trying to put the rectangle. The second thing that I'll put up is the pixel value at which I want to start my rectangle at origin point. So 50 on x-axis, that's 50 on height, 50 on width. Second thing that I'll tell is the end point. The second point where I want to end it up, right? That will be 400 in this case. That means I'm giving 2 points. What I wanted to create is on x-axis, start from 50 pixel, go till 400 pixel. On y-axis, start from 50 pixel, go till 400 pixel. So that will be a kind of rectangle. That will be 50 by, that will be a kind of square that you will see because the difference is equal, right? So I'll see a 350 pixel by 350 pixel square that will be displayed up here. Next, I have chosen of the color 0 to 55 0. This is the color of the rectangle that I want to create. 0 to 55 0 will be 0 to 55 0. That's a blue, green, and BGR color format. So that should be a green color. So my rectangle is expected to be in a green color. Third is the width of the rectangle. Thickness of the line that's creating on the rectangle. I'm choosing a thickness of 3. So slightly thicker point that I'm taking up. Similarly, I can draw a circle. I'm going to draw a circle on an image. I'll tell it what is my center at 250 pixel because that's the center of 500 by 500. So starting from the center from there, 250 pixel. Anywhere you can choose of the point, it will start creating the circle from that point. And I'm telling the radius. That's my radius, 100. Then the color. So 100 stands for 100 pixels. 100 pixel is my radius. Color is blue and thickness is 5. Similarly, for a line, I've told the starting pixel value start from 0, 0, go till 500, 500. So I'm drawing a line which is going across. Again, the color of the line is red and thickness is 2. Simple functions. Rectangle function will allow us to draw rectangles, circle allows us to draw a circle, and line allows us to draw a line, depending upon the location and the pixel size. So you can see a green rectangle, you can see a circle, and you can see it as a red line for the straight line. Now, one important aspect that we need to always realize that the coordinate system works in a downward manner. So our origin is on the top always. Our origin is on the top left. Again, that goes by the array formation because the first element in a NumPy array will be at an index 0, 0. Right? So that is where this is the index value. So our index will be 0, 0 here and our index will be 500, 500 here. Moving ahead. So that's drawing on the shape. In a similar fashion, we will also annotate on image. So how will we do that? Very simple understanding of that part. Again, we have created a blank image here. And in order to put text on that image, I will use cv2.putText. Now, putText is a function that allows us to put up a text on an image. I have told it put text. This is the image. I want to put some text. This is hello Simplilearn is the text that I wish to put up. This is the position of the text, starting position of the text. I want to start at 50 pixel on the width part, also on the height part, and 250 pixel on the width part. So it should be somewhere up and center. Then we have certain types of fonts, cv2.font. You can look at multiple types of font here, cv2.font. So you have font, Hershey, complex, Hershey, small, duplex, plain, script, and so on, italic, and so on. Let's try to use any of the fonts that of your choice you can choose up any of the fonts. These are certain fonts which are available. Very commonly used is a Hershey simplex one that allows us to get good understanding. But if you want to change it to italic, you can change it to italic as well. That allows you to get into italic text. So let's try to take font italic. It will be written up in italic text. Then I have one that stands for the scale of this. 0 to 50 is color. This is the width of the text, and CV.line AA prints the line. Okay, I'm displaying the images and writing the images on my machine. So that's how it works, as you can see here. 50 pixel on width and 250 pixel right in the center on height. So width and height. Done. So that's how you annotate on images. Let's try to talk about the horizontal concatenation. We worked around with this. So how do we horizontally concat images? For the purpose of horizontal concatenation, we will use a function called as hconcat. That's a function available in CV2 library. We have read two images. I have an image by the name nasa.jpg. You can replace with any image of your choice. And image 2 I'm reading as test2.jpg. Now, this is an image of some horses. So I'm going to resize this. Now, why this resize is important? Because when I'm going to join two images side by side, I want both these images to be same size on their aspects. So I am converting the shape and size of those images in a similar manner. What I'm going to do is I'm finding out that will show up a better alignment, right? So I'm taking the height as the minimum height. So minimum height, minimum of image 1 dot shape of 0 and image 2 shape of 0. Out of those, whichever image has lower height, I'll take that. Similarly, width I'm calculating for the second aspect from the shape. I get the minimum shape and minimum height and minimum width. Then I will use those minimum height and minimum width to reshape my both images. So image 1 resized is CV2.resized image 1 and CV2.resized image 2 with a certain width and height that we have defined over here. Now, in order to perform side-by-side transformation, we'll use CV2.hconcat. CV2.hconcat image 1 which is resized and image 2 which is resized. So I've got these two images which are resized images, and that will allow to do the horizontal concatenation of these two images. These two images will be fixed up together. As you can see, this was the NASA image that I had, and this is the horses image. This was a bigger picture, but we have got those two images affixed to each other. These two images are affixed to each other, and these are saved in my machine as well. This picture will be saved in my machine. Similarly, we can also do the vertical concatenation. When I say vertical concatenation, that means top to bottom. First image on the top and the second image is coming down below it. First image on the top and the second one is down below it. So in order to get that, we will use just a slight change. We have got the resized image here. In those images, we shall do image 1 resized and image 2 resized as a list of images that I want to join up together, and we'll use vconcat. Instead of hconcat joins my images horizontally and vconcat will join my images vertically. So I'll use that. I'll show the image and you can see a vertically aligned or vertically concatenated images. Again, I'm repeating myself that we have changed the size of those images to a standard size so that both images can follow up the same size. Otherwise, there will be a little error if the images are of not same size. Moving down, we'll talk about how we can create the custom grids of the images. When I say custom grids, I'm going to use 4 images here and I'm going to display up a square box because I'm taking up the image of the same shape. And when I say custom grid, I would need to fill up a rectangle. That's for sure because my display box is a rectangle as of now. Yes, we can choose how to create circles. That will be a little more complex topic to cover up in this session. Maybe some other day. So what we are going to do, I'm going to read 4 images here. I have read through imread function. I am resizing those images to 300 pixel by 300 pixel. Then I'm creating my first row, that is the horizontal concatenation of first image and the second image. Creating my bottom row as again, that is again going to be an image of horizontal concatenation of image 3 and image 4. So two horizontal concatenation of image 1 and image 2 and image 3 and image 4. These two horizontal concatenations, I'll do a vertical concatenation. I'll find out top row and bottom row. And I'll find out that entire grid and we'll display that grid. As you can see, I have 4 images, some random images coming from some sources, respective courtesies to those images. This is from NASA. This is from some Simplilearn web page. I have taken up those from Simplilearn web page. These images are available there as well. So I have taken up 4 images and we are working on, you can see this is a custom grid that we have been able to identify 4 images displayed in a grid form. Let's try to talk about how we can access image from a particular directory. Now this requires a little bit more understanding. So let's try to go ahead and understand step by step how do we read an image from a particular directory. Now on my machine, under my downloads folder, I have a folder called as image data, right? So I'm deliberately not keeping it in the same drive. I do not want to read the file from the same drive. Rather, I'm taking it from a different location. Though it is a same folder that I have, let's try to read it from a folder. How will I read it? I'm defining a variable image directory which contains path of my file, of my directory and not of the file name. Now in this directory, I want to look through with each image in the directory. I want to read one image. First of all, I'm convert that to grayscale, display that image, save that image, and then read the next image. So that's what I'm going to do. So how will I do it? For that, I'll use the OS library, import OS. I have already done that here. Import OS, and I'll use os.listdir. Now, when I use list_dir, that means this list_dir will fetch out the names of things which are inside my image directory. So inside my image directory, if there are multiple types of files or folders, whatsoever it may be, it will read their name one by one. Right? So all names will be captured and it will be read up by this image directory list_dir. And then I am passing that list of directories or names to my file name. File name will consist the name of the file, whatever it may be. Next, I'm checking up if the file name is ending with a .jpg or .png. So I'm covering only 2 extension of images. One is a .jpg image or .png image. If that is the case, I am writing down that as my image path. What is my image path? That is my image directory followed by 2 slashes and the file name. Correct? So that I will put up as os.path.join. So I'm joining this string with my file name string. That's what I'm trying to join. This os.path will make sure that it creates it as a path and not just a concatenation of string. Otherwise, I could have used just .join. I could have used that too. Or you can replace that with double slash. You can put up within quotes double slash as well. That will also work. So os.path.join image directory file name. It will join image directory and file name together, and I'll have a path of the entire image. So what eventually we have done, we have actually located the physical path of that image in my drive. Now I can read that file from that image path, read that image file, convert it into grayscale, and I'm displaying that processed image through I am show. You can also save that image. That's what I've done here below. I'm saying that my output path is os.path.join image directory, naming that as directory name as processed, and I'm naming my file name as grayscale underscore the same file name that I had. Original image, whatever I had, underscore the file name with a gray name. Just a grayscale keyword added before the file name. That's what we've done. cv2.wait key to wait for the windows and destroy all windows to close it. Now this is outside the for loop. So once we have displayed through all the images in my image directory, which I have in my sample case, I have 4 or 5 images. So in my particular directory. So make sure if you're trying practicing at your end, this path is a path of a folder which contains certain images, certain number of images. then that should be in a JPG or PNG format. If you want to include some other format, change the extension here. Right? You can use any extension of image. Let's execute. You see that I have a car. This was a blue car. It's coming up in a grayscale format because I've converted it into grayscale. I'll close it. The second image is some work, some fire rescue work going on. An ambulance is standing there. I've closed this too. This is a motorcycle from Harley Davidson, which I can see here. Then you have another bike coming from somewhere in the mountains. All these are images converted, and this is another ambulance that I can see here. So this is one typical data set that is available about training and testing. That is a RoboFlow data set available. So I'm taking these images from RoboFlow. So that is the part that we have done so far, dealt with so far. Now we need to talk about some image processing strategies. Let's go to the image processing part. So in terms of image processing, there are a lot of things that can be done in terms of image processing. I'll go back to my presentations first. That would be a better option. Okay, here it is. So what are image processing techniques? So when I say image processing techniques, that means applying certain process by digitally analyzing the image and enhancing, modifying image, use some manipulations of the image that allow us to reform our image. When I say reform image, that will I'll try to make some adjustments into the images. Typically, we'll talk about these 5-6 things in terms of image processing techniques. We have already talked about resizing and cropping the images. We have talked about rotating and scaling the images. These two things we have already talked about. We'll talk about what is image thresholding. That's something we need to understand. What is image thresholding? Thresholding is a process in which we will take a binary image. What we try to convert is a image into a binary form. Now, when I say binary form, it means I'm converting into a black and white form and not a grayscale. Grayscale is slightly different from binary. A kind of binary image, a black and white image, that will create through image thresholding. We have two types of image thresholding. One is called as adaptive thresholding, and the second one is just the thresholding. Then we'll also look at 3 types of blurs, what is a Gaussian blur, median blur, and a bilateral blur. We'll look at what is edge detection, what is edge first of all, and then what is the edge detection part, and some arithmetic principles of addition, subtraction, and multiplying. What happens if we add 2 images? What happens if we subtract 2 images or multiply few images? We'll look into that part. Post that, we'll talk about some real-world projects, and in the real-world projects, we'll talk about basic face detection. So we can do a lot of things in real-world: driving, self-driving cars, live video streamings, maybe traffic signal jumps from people. You can look at face recognition, finger recognition, thumb recognition, whatsoever you can think of. Anything from healthcare to traffic to attendance or to many other things. So I'll do a basic, simple understanding of basic face detection part that we'll do right now. Remaining things we can practice later. That will be the all. Let's also wrap up with this presentation part and we'll go into the coding part after that. Some best practices and standard operating principles that we follow. We need to make sure that we use effective image loading and processing techniques, wherein I would say that try to use either OpenCV library or NumPy library to read the 3D arrays and process them through NumPy. Do not try to read them in a pixel by pixel values, because that will allow your machine to slow down a lot, and don't read each pixel one by one. That's one thing. That's the second thing that it talks about. Leverage the vectorized operations with NumPy. Start implementing or using NumPy as much as possible, because that will allow you to process the data faster. Otherwise, things will become very, very slow. Utilize hardware acceleration. That's what it talks about in the hardware acceleration. If there is a possibility you have GPUs or TPUs available, use them to best possible mode. Create a modular and scalable code. Some best practices that we follow. We'll talk about the last slide after we're done with the coding part. So let's finish up that, and there should be another 5, 10 to 15 minutes to work around with. So we're talking about image thresholding. We have seen rotating and scaling images. Let's try to talk about image thresholding. So how do we perform threshold? So the thresholded image, again, I have read the image and I've converted that image in a grayscale format. So one step, I've done both things. Read the image and convert the image into a grayscale format. First of all, I've converted the image because all these thresholding principles and everything will work in a grayscale image format. All transformations that we do in a grayscale format. Transformation is really cumbersome to do it in a three-dimensional array. It's a very simple thing. If I'm trying to rotate a three-dimensional matrix, or if I'm trying to put some application on a three-dimensional data, that will be, or some matrix calculation on a three-dimensional data, that will be more complex as compared to two-dimensional. A grayscale image is a two-dimensional image. So I'm trying to do that transformation on a two-dimensional image, and that is why I'm converting into a grayscale format. So another operations that you can see, I can write it down that cm2 dot, and I can put it up CVT color here as well and convert it to grayscale. But I'm telling it the read function that read this image and read it in a grayscale format. So I'm avoiding one step of CVT color directly. Then I'm finding the thresholded image by using cv2.threshold function. Three aspects: image, the pixels that I want to understand is pixel from 125. Now this is the color codes that I'm calling it. So from a grayscale image, capture pixels from 127 to 255. That means the darker pixel. I'm leaving out the lighter pixel and convert them and thresh binary. It means my pixel intensity is more from 125 to 255 is high intensity pixel. I'll give that as a value 1. If it is less than 127, then I'll give that a value 1, 0. That's how it works. So that will create up a 0, 1 image, right? Then adaptive threshold image is taking the same measure here, adaptive threshold, but the understanding is that we'll look at the mean values of that. In adaptive threshold, we have a mean value. We'll look at the mean terms and we'll convert them into binary format using mean. That's the only difference that you will see there. Let's have a look. So this is dark color and light colors wherever I have the blood. If you just concentrate on this image slightly, wherever I had the dark colors, you can see the blacks. Wherever I have the light color, you can see the whites. This is for binary thresholding. This is for your adaptive thresholding. So you can see that it kind of little more adaptive thresholding. Your intensity of the color is kept into the picture, but the mean value, instead of directly going to the 0, that is converted to mean, and those mean values are converted to black and white. So instead of pixel values, suppose for example, I'll say that in a particular case, let's say I had a blue color somewhere on this face, maybe, right? So that color will not be directly converted because of its total intensity being low, it's been white. But the total intensity, instead of making that total intensity, I'll take the average intensity. I'm taking the mean intensity of those. And that is why we are converting them into that fashion. So you can see some light colors, light intensity and lower colors there as well. To the blur part, we have filters available like Gaussian blur, median blur, and bilateral filter available for blurring, image blurring. We can directly implement that. For example, implementing Gaussian blur, cv2.Gaussian blur on this image. This is the dimension of the blur that I'm trying to put it up. Let me put it up 5 by 5 blur. So 5 by 5 blur that I'm going to put up. Similarly, for median blur also, I'll put it up for 5. And I'll put a bilateral filter for, let's say, 25 by 25. Okay. So you'll get 3 types of filters, 3 different types of image. Gaussian blur is going to create a blur 5 by 5, a square box of 5 by 5. So some blur, you can see that it's not actually very clear picture, right? It's a blurred picture. Similarly, this is for your second blur, which is a median blur, and third blur that you can see. Again, these all are mathematical transformation. It's not just a simple direct function. In order to go through with that, we need to go through with the actual functionality and array transformation that is being used. Again, WAP-affine function will be utilized in this, and it has used some matrix transformation strategies. And this is your third bilateral blur. Typically, you might not see any blurring into this, but you can see blurring, slight blurring on the backdrop. That part that you can see, slight blurring on that one because I've reduced down the blur values. Similarly, you can do an edge detection. In terms of edge detection, we have two different types of edge detection. One is called as a Sobel edge detection. Another one is called as a canny edge detection. Both of them is, typically vary in terms of a methodology detected or methodology used to detect edges. To be very precise, Sobel edge detection method uses or reads vertical lines and horizontal lines. That's the idea behind them. So that is what it reads, either horizontal or vertical lines. Similarly, canny can also detect the curved lines as well. It can also detect the curved lines. So canny is one of the prominent method or a class that is used to detect edges. We have two different classes like Sobel class and canny class that can be used to detect edges. Now, how and when edges become important? The edges become important when we have to identify an object. So when we go on to the advanced versions of OpenCV, you will find we can use OpenCV to detect objects. In order to detect an object, we must identify what are the edges of the object. So that becomes very crucial to understand what that object is and classify that object and make informed decision about that object. To do so, we can use Sobel filter, that is cvd.sobel image cvd. I want to check out for 64f, and this is 1 and 0, defining my case size as 3. Here coming Sobel image cv2.64f with this prepositions and case size is equal to 3. So what I'm trying to ask it to detect edges, this is a vertical edge, this is a horizontal edge to be very precise. This is x-axis and this is y-axis. I'm combining those together to create a common magnitude. That means in my image, please capture both vertical and horizontal images, vertical and horizontal edges, and show me both together. So I'm combining them using cv2.magnitude, both type of edges. Similarly, canny edge detection, I do not have too much of things. I do not have to tell vertical, horizontal. It will by default find out all the edges. Canny image, I'm putting up the edge size. This is the minimum amount and maximum amount that I'm looking for edge to be for something to be considered as an edge. That's what we see here. See, this is the example of Sobel edges. If you try to look at that very closely, you will find that it is a combination of vertical and horizontal lines that it has drawn up as the part of edges. Similarly, this is the canny edge. In canny edge, you will see that it's not actually vertical and horizontal lines only. It is curved line as well, which has been detected very clearly. That is the canny edge detection part. Into the image arithmetics that we'll talk about. Some mathematical principles. You would have used NumPy addition function, NumPy subtraction function, NumPy multiply function. We are going to use the same functions here as well. Dividing a NumPy, a CV2 array of image, adding an array, subtracting an array. What you will see, the output will be, if I use cv2.add with image 1 with image 2, as we have seen, read two images, the NASA image, that was the image of astronauts, and the test2 image, that was the image of horses, right? Now, let me just put up two more display functions here. I'll display those two images as well. cv2.imshow. My image was, let's say, NASA. That's the window name I'm putting up. The image name is NA. It was, let me just see what was the name that I put up. Image 1. My bad. Here it is. That is image 1. That's the variable name. I want to show you that actual images as well so that you can understand. So image 1 is the NASA image. Then I'll put cv2.wait key. So I'll wait for key to be pressed to take this display off. And we'll put up another image here to display the second image, that was test2. Image 2. Okay. So I'll display those two images. We have not done too many things big here. Instead of NumPy add, I'm adding the arrays using cv2 function. That's the thing. Adding two arrays using cv2 function. So I'll get added image, cv2, and that will be superimposition of these images. Look at this. This is the NASA image. Keep an eye on this and keep it a little bit in memory. This is your next image of test2. This is your third image that you can see a superimposition. If you look at this, You can see these flowers and green ones coming from the bottom, which are displayed up here, but you can see a superimposition here. Then you can also see this is another image where you can again see it's one image subtracted. I have subtracted certain colors, so the background image or the image of horses is little bit missing. And then finally you see this is a combination or a multiplication of a multiplied image, and I can hardly measure anything, but this is the multiplication of all the data points. That's how you can do the different aspects about the addition, multiplication, or the arithmetic part. Finally, we'll also work on the last part of this aspect, and that is the face detection algorithm. So in order to go through with the face detection algorithm, we will talk about in terms of how we can detect a face. In order to detect a face, it's crucial to identify where is the face located in the entire picture. So that becomes critical. Again, we have a longer version of doing this where we can go into a non-abstract method or lower level programming in order to low level programming into this, or we can use a pre-trained model which are available through OpenCV. So if you have installed OpenCV on your machine, wherever OpenCV gets installed, you will have a folder by the name data, and in that you will have a folder by the name Har Cascades. That folder will contain certain pre-trained XML files that are trained for a particular type of recognition. Like you have to detect face, if you have to detect pose, if you have to detect, let's say, people, there are some different types. If you have to detect eyes, you can have different types of XMLs which are available. And these are pre-files created by OpenCV, available in OpenCV, which we can utilize to detect faces or other activities. That's what we're going to do here. So what I'm going to do here is I'll import OpenCV2, creating or initializing our pre-created Har Cascade classifier. Now, Har Cascade is a generic name. All the Har Cascade classifiers are meant for certain reason. Depending upon their reason, they have a different name available. So we are going to create up an instance of Cascade classifier function. This Cascade classifier function will have a potential to read a particular type of pre-trained model from Har Cascades and implement that on any image. Okay, so I'm telling it that please create an instance of Cascade classifier that will classify certain thing. What it is going to classify is I'm telling please do this. So I'm asking it to read from cv2.data.har_cascades plus this classifier. This is har cascade underscore frontal face underscore default.xml. This particular XML file will be able to capture just the frontal face, just the frontal face of the image. Any frontal face in the image will be there. What it will do, I'll show you that part. So I'm reading that. So I've read that, created or instantiated that using face cascade variable. Reading the image, the NASA image I've read up. Again, to detect, because this works on the concept of finding out the edges to locate faces. So I'll convert that image back to BGR, from BGR to grayscale, and then we'll work on that. So converting image to a gray image, I'm creating a gray image here by cv2.color, cvd color, image, comma, cv2 color, BGR to gray. We got the gray image here. Now, we'll detect the faces. Now, what does this faces means? Because in an image, we can have multiple number of faces. So what I want is 4 things. What is the starting point of an image face? If there is a face in an image, at what pixel it is starting at? On that pixel, what is the width of the face and what is the height of the face? 4 different things. This fast face cascade objects function detect multi-scale is going to detect multiple number of faces in my image with certain parameters that I'm trying to tell it. The first parameter is the grayscale image. The scale factor that will allow us to make sure if there is a face that is in the backdrop or it's coming smaller because of it is in the background or it's too far off, the scaling factor will help us. Right. Second thing we'll look for is the min neighbors. how many neighboring faces it can detect, and min size, what is the pixel size of a shape or a face that I want. If there is a space of less than 30 by 30 pixel, it will ignore it. So if I put this bigger sizes, it will only detect big faces. If I put as small size, it will try to detect small faces. Then this will return me an object that will be consisting of 4 values for each face. Each face detected, it will show me 4 values: starting coordinates, the width, and the height. Now I'll read those and draw a rectangle on each of those. So in faces, I'm reading 4 terms: x-axis value, y-axis value for the starting point of the face, then the width. So from x point, move this much right, and from that same starting point, move this much down, and that will be your rectangle completed. So we'll create that rectangle. So I'm creating cv2.rectangle on an image. Starting point is xy, x-axis move x plus w, y-axis move by y plus h, and you will get this color, and this is the green color, BGR, and I'm taking a width of 2. So all faces detect multi-scale function will be displayed through this. Let's try to have a look. Again, I am show the picture, and I am right to save that detected image. And you can see that it has detected all the faces, exactly all the faces which are there. So it's a pre-trained classifier of OpenCV that we have worked along with. So that would be it in terms of OpenCV Crash Course part. Team, this file, I'll try to see if I can make it available in the recordings. And we'll see again in some other course with OpenCV. To know further about OpenCV library and get deeper into the mathematics and how does these function works, you can refer to Simplilearn's page. You can visit simplilearn.com, and thank you very much.
Thank you guys for watching this video. I hope so you would have enjoyed our today's video on OpenCV.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.